Oh hey, and welcome back to What the Math. Today we are going back to space, and this time we're actually going to orbit. Now before we do this, let me introduce to you Albatross 3. Actually, this was my original plan. Originally I was going to just launch this airplane into space and show you how it's done, but instead I'm going to do something different. I'm going to build a plane from scratch and then launch into space. I'm going to make something completely smaller than this, something really simple and something that is a little bit easier on the eyes. And there we have it, introducing Pi 16. It kind of looks like F-16, very simple design, basically very tiny airplane. It's actually about half of the size of the rocket that I tried to launch in the last video, and it looks relatively small and most likely not space ready. Let's find out if it is. So I'm going to launch this and going to try to take off and basically show you how space exploration can be achieved by going sideways, but going horizontally instead of going upwards. Now in this video I'm also going to demonstrate to you two things. First, I'm going to show you how to achieve spaceflight horizontally. I'm also going to talk a little bit about orbital velocity, and at the end of this video I will actually show you how to calculate orbital velocity using your graphing calculator or GGC. I'm actually going to show you how to calculate orbital velocity for any height. So basically, if you want to orbit at 200 kilometers, what orbital velocity do you need? And I'll show you exactly how to do this. So if you don't want to watch me taking off and trying to get into space, you can skip the video and press the button, scroll forward and get to the point where I'm actually going to explain how to calculate orbital velocity. But for those of you who want to watch me fail and or succeed, let's see how I do. This is basically the airplane. As you can see, it's very eager to take off. It's already moving. Really small, really simple. Kind of looks like F-16, but not really. Has these really funny looking wings, and unfortunately it doesn't really have very much lift. So it is an airplane, but it's not a very good design, not a very good airplane. I'll show you what I mean by this. It needs a lot of speed, it needs a lot of lift, but unfortunately it doesn't have enough to support itself. So it's going to take off and gain altitude really slowly. Alright, so I'm about to take off, and there we go, we're in the air. Now, this airplane is really badly designed, it's really heavy, it doesn't have enough lift. Lift is represented by aerodynamic arrow right here, and as you can see, it's sort of increasing, but not enough for me to go into the air really fast. So I'm going to be inching my way toward the sky. Now, the way this works is, I want to go sideways at approximately 20 to 30 degree angle, and I want to reach the area of atmosphere right above 12,000 kilometers, where the air is really thin, which will allow me to basically increase my speed dramatically. So I'll probably be able to go to like 800 meters per second, at which point I will be able to reach a really high velocity and go really fast sideways. Now this is exactly what I want, because turbojets, using the turbojet engine, do not require much fuel. As you can see, my fuel actually is going down really slowly, because they're using these big looking hole thingies to suck in all kinds of air, or basically oxygen, and use oxygen to propel themselves. So this is a turbojet engine, but there's a thing about this engine. This is actually a futuristic model called Rapier engine, which is based on a realistic engine that we are developing currently. It's actually being developed in England. It's called Sabre engine, and it's supposed to come out sometime in 2020. And this engine, the beauty of this engine is that not only is it a turbojet engine, basically it can propel an airplane really nicely in the air or in the lower atmosphere, but it's also a hybrid engine that will then switch off, and when you reach space it can actually turn into a space engine. And this is the beauty of this prototype that I have right here. So it might not be the most powerful engine, and it might not take me into the atmosphere really fast. As you can see, I'm actually going really slowly, but the beauty is that it's a hybrid. So if I show you right here, I can actually, well, right now it's on automatic mode, but I can actually switch it from air breathing mode to a space mode. Unfortunately, space mode wastes a lot of fuel, so I'm not going to do that until I'm really in space, because I need all my fuel to reach the orbit. I'm going to actually increase my angle a little bit. This is a beautiful engine, and it doesn't exist yet, but it will exist hopefully by 2020. And we will hopefully be able to use these types of hybrid airplanes, also known as SSTO, which stands for single stage to orbit. which means basically that you don't have to make rockets anymore. You can basically reach space with an airplane. So this is the beauty of this design. Now it is a very simple plane, very small, doesn't have a lot of fuel, but if I did my math correctly, I should have enough fuel to reach orbit, to orbit around the planet, and to then even return. Now I won't be able to land back at the airstrip where I took off from because well, first of all, this plane is really hard to control. Second of all, I haven't planned it at all. And third, because I basically suck at landing. But however, I am definitely going to try my best to reach some kind of a land and try to land somewhere. Alright, so we're at 10 kilometers right now. As you can see, my speed started to increase quite highly, quite dramatically. I'm gonna go a little bit higher. My air intake, which is actually on the bottom right here, is quite low, but I'm still taking in some air to help my engines breathe. So right now I should start increasing my speed. I'm going to increase my sideways velocity, my horizontal velocity, to as high as I can. I'm basically going to try to go almost horizontally and increase it dramatically. I'm going to increase it to at least 800. As you can see, my aerodynamic forces are quite high, so I am being pulled or pushed into the sky. And this is basically what the lift is. Lift is when you have, I guess you could call it wind, coming toward your wings and pushing you upwards. So essentially this is what's making me go upwards and not forcing me downwards. Right currently I'm at 17 kilometers. This is actually a perfect height to have in order for me to increase my speed, and I'm going at approximately 750 meters per second. I need to go much faster. My orbital speed actually has to be approximately 2400 meters per second, so I'm still quite a ways off from what I need, but I'm getting there. And as you can see, Jebediah Kerbin is super happy about the situation here. Now in a few seconds you'll hear a whoosh, and this is when my engine will switch to the space mode from the air mode. But as you can see, I'm going really fast. I can see the clouds down there, the horizon, and everything else in between. Alright, almost a kilometer a second. Almost a kilometer a second. Doing really well so far. And the engine, there you go. So this is my space engine now. So now I don't have to worry about it too much. As you can see, fuel started decreasing really fast. Now I have to make sure to maintain, I have to go back here and maintain my apoapsis. I have to make sure I don't go too high up, because this is very important. I have to reach an apoapsis of about 65 kilometers and then stop my engines, because I don't want to overshoot. I don't want to go too high up. I want to go to a very specific orbit of approximately 70 kilometers above the planet. Now I'm moving really fast, so right about now I'm going to stop my engine now and basically just float in air. And at this point right here, I'm going to activate my engine again and actually blast it toward the horizon, because I want to go sideways again. So as you can see, currently I'm moving at almost 2 kilometers per second. Mr. Jebediah Kerbin is really happy. We can actually check out what he sees. This is what his view is like. He can see the sky, he can see the moon, he can see the space, and he can see his panel. But my speed is slowly falling because I'm still in the atmosphere, and it's still kind of pushing me basically away from my velocity. But this is beautiful so far, and I have enough fuel to basically get into orbit. So after about 1 minute, I'm going to blast my engine and get into a very beautiful circular, or almost circular elliptical orbit. Alright, so we're at 63 kilometers. I'm going to increase my velocity again, and I'm going to watch my orbit right here. So I have to make it into a circle. So let's watch it as it's increasing. And right about now, it becomes a circle, and perfect. So I'm going to be moving in a circle. I still have enough fuel actually, and this is not real. So it's an elliptical orbit, it's an ellipse, and my highest point is going to be 132 kilometers. Now, if I really wanted to, I could actually make this into a perfect circle by increasing my speed right here and making this 132 as well. And all I need to do is I have to increase my speed by 65 meters per second, which is really easy. And I think this is exactly what I'm going to do once I reach that point, just so I can have a perfectly circular orbit. because right now I'm actually, if I move the way I'm moving right now, I'm going to fall down back into the atmosphere right here. However, I don't want that. I want to go in a perfectly spacious circular orbit. Alright, so I'm ready for my final blast off, and this will give me a perfectly circular orbit in about 7, 6, 5, 4, 3. I might as well just do it now. Doesn't have to be precisely at that point. And there we go. Alright, so let's check out our orbit, and look at that, it's a perfect circle. So I'm finally in space, and I'm finally orbiting in space in my beautiful Pi 16 airplane. So this is actually an airplane in space. Isn't that cool? That's pretty cool. So let's just accelerate time and see what it looks like as I'm orbiting around Kerbin. Daylight. And look at that, going around the planet in a perfect circle. Or almost close to a perfect circle. And as you can see, my orbital velocity right here is approximately 2200 meters per second, plus and minus 2 meters per second. And I'm going to be flying like this pretty much forever, unless I actually want to return to the planet, which I do want to do at some point. But while I'm actually flying around Kerbin, let me show you how to use a orbital velocity formula to calculate the velocity that you need to achieve at certain orbit around Kerbin. I mean, this works for Earth as well, but specifically I want to do this for Kerbin right now because we just want to explore this planet. Now, before I start, this is the actual formula. This is the actual explanation for how it's found, but the formula for orbital velocity is 600,000 meters times square root of 9.807 meters per second square divided by 600,000 meters plus h, which is your height in meters. Now, this value right here, this is your gravitational constant. This is g, basically. It's the same on Kerbin and on Earth. And 600,000 meters is the radius of Kerbin, so it's actually much lower than on Earth. And h is your height, basically how high you want to be from the planet in meters as well. So let's go into so I'm gonna switch to this, and let's go into the graphing calculator. I'm going to use my favorite TI-84 Plus. I'm going to turn it on, and I'm going to show you how to find this. So what you have to do is, first of all, let's quit here, go into your y plot and enter the following. So y equals 600,000 multiplied by square root, so this is second right here, second x square root of, so I would suggest entering this in brackets just so we don't make a mistake, brackets, and first value, if you look back here, first value is your g, so enter your g, 9.807 meters per second square, but that we don't have to enter the units, divided by, and now we enter 600,000, which is your radius, plus, now here I'm going to make a small correction. I'm going to, because I want to measure things in kilometers, I'm going to multiply my x by 1,000, so it's going to be 1,000x. Essentially what this will give me is, it will give me the value of y for x in kilometers instead of giving it to me in meters, because we don't really want to calculate this in meters. And then I press enter, and if I plot the graph, you can see that this is what it looks like. I can change my window to show it to you a little bit better. But basically, this is on ground level, and this is what your velocity should be on ground level. Let's just change the window a little bit. Maybe this will be, let's just say, 2,500. And this here, I'm going to increase to 3,000. So let's check this out again. So basically, as you can see, it's not exactly a linear function. It's more of a well, it's a mixture between exponential and quadratic, but it's most likely exponential. But basically, it's a graph or a line that starts at the ground level right here, and this is the speed at ground level, and then it actually goes down dramatically. So if I trace this, you can see that it actually goes down dramatically. So as you move away from the planet, your velocity, your orbital velocity decreases as well. Now, to find a specific value for what orbital velocity you need when moving around Kerbin, you need to use the calc function. So second calc value And let's just say I want to know what orbital velocity I need at 300 kilometers. 300 kilometers. At 300 kilometers, I have to move at exactly 1,980 meters per second. So that's a very precise value. So basically, at this velocity, I will be able to orbit around Kerbin in a perfectly circular orbit. Now, if you want to just check all of the values, remember there's a table here as well. And as you go down the table, so this is in kilometers on the left. So let's just say usually the atmosphere around Kerbin ends around 70 kilometers, and at 70 kilometers, if you just want to orbit right there, you need to have a velocity of 2,295. I am currently at 132. Oh, this is kind of getting slow. 132 kilometers. Let's find out how much I need to, how much velocity I need at 132 kilometers. And it's right here at 132 kilometers. My speed has to be approximately 2,196, and that's exactly what it is. It's plus minus 1, but it's exactly what it is. So basically, you can use this to calculate any kind of orbital velocity for a specific value of height, or basically your distance away from the planet. So anyway, so this is what you would use the mathematical function of your GDC for. But listen, I'm kind of getting a little bit lonely in space here, so I might as well, first of all, let's do a little bit of a space look around here. Alright, this is cool, this is space, nice. Well, it's kind of getting boring, so let's just actually try to get back to the planet. So I'm going to decelerate my my velocity, and I'm basically going to crash land, or try to land, but most likely crash land back onto the planet. So before I do this, I need to position myself in a specific location. So this yellow cross thingy shows us the vector away from my velocity. So I'm just going to blast my engines toward this vector until my other side of my orbit, which is going to be right here, until it actually starts decreasing and until it crosses into the Kerbin atmosphere. Because when it does that, I will be able to use something called air braking to stop or to decrease my velocity and eventually land on the planet. Essentially, I'm using air pressure or air braking to slow down instead of using the fuel. So let's start doing this right here. And right here, I'm going to start decreasing my velocity. Oops, that's the wrong button. Decreasing my velocity by approximately 84 meters per second, which is really not that much. And this will give me enough speed or will take away enough speed for me to basically start using air braking and slow down, and then eventually try to land. Alright, so I'm gonna start doing it right now. So 84 meters per second, a little bit more, and that should be enough. Okay, so let's see what I have here. Alright, my periapsis, or my lower part of my elliptical orbit, is at 31 meters, or 31 kilometers, and this is exactly in the lower atmosphere where there's enough air pressure to slow me down and to help me enter the actual atmosphere. And if everything goes right, I'll be able to return to Kerbin, and if everything goes really right, I'll actually be able to even land, because I do have enough fuel to kind of get to the planet and land, but I probably will not be able to land because I am not very good at it. So let's find out how this goes. Alright, sunlight, and I'm entering the atmosphere. So here I am falling into the atmosphere. You can see the atmospheric gauge started to increase, meaning that we can now have atmosphere slowing me down. My speed will also start decreasing in a moment. But essentially this is it. So hopefully this was kind of clear for you how to basically get into space, and I hope I explained to you the importance of moving sideways to get into space, because going up is not as important when you're trying to start space exploration. It's really all about sideways motion, because you're trying to enter free fall, or essentially free fall around the planet, and to get into free fall around the planet, you really have to move sideways really fast. Alright, so let's wait for me to start burning into the atmosphere, and then I will try to land. I think Jebediah Kerbin is ready for this, and I think I'm ready for this as well. So I'm getting really close to the planet right now, and I'm about to start burning into the atmosphere. Jebediah Kerbin is super happy about this. I hope I don't kill him, because it looks like I might be actually landing onto an actual surface and not water this time. And this is actually good news because I can then use my gear, I can release my gear and try to land. Alright, so here we go with the burn. This will slow us down dramatically. And because this is an airplane design, whenever I burn down, I actually start facing with my nose forward, which is perfect for me because I can then, essentially I can then just start flying right away. Now, I do have to switch my engine back into the atmospheric mode, so I'm going to do this right now by clicking on it and by switching it into the air breathing mode. Alright, so I can now start controlling my plane. I'm not going to use my engine just yet because my speed is pretty high and I'm still quite high up, but I am going to try to land somewhere over there, and hopefully if everything goes well I'll be able to actually land on the planet. However, I have failed before, so I don't have many hopes for Jebediah Kerbin. Luckily, every time he disappears, he reappears again, so he's actually immortal. Alright, so I'm not going to use my engine just yet. Just like the shuttle program, I'm going to just glide down to the planet and try to get as low as possible using nothing but my wings. Actually, no, I do have to start using my engine because I'm not really pulling up. I'm not pulling up. Pull up. No, no. You're going down too slow. I mean, too fast. Pull up, pull up, pull up, pull up. I'm falling too fast. This is too fast. Okay, I think I'm getting a little bit better at this. There we go. Okay, I need to start slowing down, but not this fast. Okay, I'm gonna decrease my engine burn and slowly move toward the planet. So my gear is released. I'm sort of ready for landing, but there's a very big chance that it might not be success, but let's find out. Now, the beauty of using airplanes for space travel is that not only are you saving so much fuel, but you're also saving a lot of money on not wasting parts. When you're launching rockets, to launch a rocket into space, you actually have to have a lot of different stages which actually are lost in the process. You can never recover them. They're actually destroyed in the atmosphere, and so that's why space travel is so expensive currently. However, if we are able to invent this type of engine by 2020, the space travel would drop in price dramatically. It will be so much cheaper, it will be so much more convenient, and pretty much everyone will be actually able to afford it, because here you're only really spending money on fuel, and your entire plane is able to return to the planet safely without wasting anything. So that's why Saber engine, or as it's called, Repair engine in this game, is such a beautiful invention. Hopefully it does become reality sometime soon. Alright, so I'm inching my way toward the ground even faster, and I do have to be very, very careful now. I have to go a little bit slower than I'm going right now, but I can't really do anything about it. I'm going really, really fast. I can already see the ground, and so here goes nothing. This is actually a hill. That's not a good idea to land here. I'm gonna try to maybe avoid it and land on a flat land, but this is a really difficult maneuver. Landing on the hill is probably even more difficult, so let's try to maybe slow down a little bit more. I am going really, really fast right now, but slowly falling. Oh, there we go. This is actually a pretty nice area, so if I'm going to be landing, I should be landing right here. So let's try to inch our way toward the ground, and a little bit more, and a little bit more, and just a little bit more. Not so fast, not so fast, not so fast, not so fast. Not so fast. Alright, now I'm actually gliding. I'm actually gliding. And, oh! No. Brakes. No. Okay, it's wobbly. It's really wobbly. No, don't fall. Slow down. No! Oh, there we go. Beautifully done. And excellent. We survived, Jebediah Kerbin. You can get out and go explore the world. It's time to plant another flag right here. This is our first successful orbit, and return back to the planet safely. You're the hero of the planet. Let's plant the flag and get back home to our wives and children. Excellent job, and thank you for surviving this. Alright. Okay, so I did the orbit and return, and that's it. My plane survived, my hero survived, and we all survived. Alright, thank you for watching. Please subscribe, check out some of the other videos I'm going to be posting, and next time I'm going to do a little bit more math in Kerbal Program and show you some more functions on your GDC. Hopefully you enjoyed this video, and hopefully now you know how to calculate your orbital velocity depending on the height that you're going into, and hopefully you enjoyed my landing. Thank you and bye bye.